For decades, our vision of the prehistoric world has been dominated by one creature, a massive 7-ton predator that ruled its ecosystem with absolute authority. To find the direct, living descendant of that ancient giant today, you only need to look as far as a backyard coop. The common chicken is the T-Rex's closest living relative. This connection is based on more than just physical appearance. Paleontologists successfully extracted preserved collagen, the primary protein in animal connective tissue, from a T-Rex femur found in the Hell Creek Formation. This chart shows the molecular separation of those ancient proteins. By analyzing these sequences, scientists compared the dinosaur's biological makeup to the DNA and protein structures of living animals. The data revealed a 60% molecular overlap between the T-Rex and the modern chicken. In terms of biological structure, the closest match was a bird, not a reptile. These findings reshape our understanding of extinction. The dinosaur lineage survived the end of the Cretaceous period and remains a part of our daily lives. Taxonomically, birds belong to a specific subgroup of dinosaurs known as theropods. Biologically, they are living members of that prehistoric lineage. Feathers are a prime example. Millions of years before flight, small, ground-dwelling theropods grew primitive, hair-like feathers for insulation against the elements. Their skeletons evolved similarly. Bipedal dinosaurs developed hollow, honeycomb-like bones to reduce skeletal weight, increasing their speed and agility long before those same structures were used for flying. We even see these connections in their behavior. Modern avian habits, such as building complex nests and sitting on eggs to provide body heat, trace back directly to ancient dinosaur fossil sites. These avian traits were specific to the two-legged theropod family, entirely absent in massive quadrupedal branches like the armored Triceratops. Core avian characteristics, from the skeletal architecture to nesting behaviors, were already operational within the dinosaur kingdom millions of years before the first bird took flight. 66 million years ago, a massive asteroid impact triggered a global extinction event. The ensuing dust clouds blocked the sun, causing the Earth's vegetation and food chains to collapse. This collapse favored the small. Massive predators like the T-Rex required enormous amounts of calories to survive, and as their food sources vanished, they faced total starvation. Smaller theropods survived because of their efficiency. Their low body mass meant they required significantly less food, allowing them to scavenge and survive on the scarce resources of a dying world. In the millions of years following the impact, they adapted further. Heavy, tooth-filled jaws were replaced by lightweight beaks, which allowed them to access seeds and insects hidden in the debris. Their feathers, originally developed for prehistoric insulation, became vital for regulating body heat in the unstable and cooling global climate. The asteroid impact acted as a brutal evolutionary filter. It selected for the smallest, feathered, and most resource-efficient members of the dinosaur family, leaving the giants behind. In the modern era, that surviving lineage has achieved a massive global population. There are now tens of billions of these descendants alive on Earth today. It is a striking transformation. The direct descendants of the ancient world's most feared predator have been domesticated for large-scale agricultural production. They are no longer the rulers of the ecosystem. Instead, they have become the ubiquitous stars of global fast food menus, found in nearly every corner of human society. The T-Rex bloodline survived by remodeling its physical architecture to fit the needs of a new era. That process meant trading immense scale and bone-crushing power for a coat of feathers and a famously comedic head-bobbing walk. The next time you see a chicken, remember that you are locking gazes with a genuine dinosaur, an ancient lineage that outlived an apocalypse.